You may have heard of water being referred to as H2O, but how exactly do hydrogen and oxygen atoms form H2O? How do they form water? In this video, we're going to take a look at chemical bonding. So how exactly does hydrogen and oxygen bond? How do they come close together? We're going to talk about that. First off, let's take a look at the atom. If you remember, the electrons are located on the outer part of an atom. And a matter of fact, we talked about there's different levels or different shells. Now, when we talk about bonding, what's most important are the valence electrons. Those are the ones in the outermost level, or the ones furthest away from the nucleus. Now, when we look at an element to find the valence electrons, we can actually quickly look at the top of the periodic table. The top of the columns, or the families or groups, actually has a Roman numeral. Starting at 1, and you're going to realize the highest number is actually 8. Because atoms can't have more than 8 valence electrons. So take a look, hydrogen has 1, going across the next column has 2, 3, 4, 5, 6, 7, 8 repeats itself 3 times, 8, 8, 8. Then we're back to 1, 2, 3, 4, 5, 6, 7, 8, with the exception being helium, which only has 2 valence electrons. So that's a pretty neat trick to figure out how many valence electrons does a certain element have. Now, before we get to the bonding part, let's talk about those valence electrons. A lot of people actually use what's called an electron dot diagram, also called a Lewis dot diagram, to show the valence electrons. So if we have hydrogen, we have 1 dot, or 1 electron around the symbol, H. Right? If we take a look at helium, we'd have 2 dots. Now, we mentioned the maximum you could have is 8, and that's called the octet rule. They want to have 8, and if they don't, okay, there's almost like a vacant spot there. I think of it like a cafeteria table. There's 2 seats on each side, and until we have 8 people, we're not fully content. Now, going based on that example of, say, a lunch table, say, for example, there's only 1 valence electron, for example, hydrogen. It really easily wants to get up and move to a different table with a lot more people on it. So it's kind of like this little game of tug-of-war. If there's a table of 7 and there's a table of 1, quite easily that 1 leaves to join that table of 7. Again, there's the octet rule. Every single table or atom wants to have 8 valence electrons. Okay, if there's a table of 2 and there's a table of 6, very easily those 2 are going to leave and go to that atom that has 6. This is how that chemical bond happens. Again, take a look back at that H2O example. Remember, hydrogen has 1 valence electron, oxygen has 6. So if you think about it, oxygen can pull 1 valence electron from hydrogen, and it still has room for 1 more. So that's why we get 2 atoms of hydrogen and 1 atom of oxygen. So it feels perfectly happy because oxygen now thinks it has 8 valence electrons, and the other hydrogens don't have any. They left, and that's why they're actually closer to oxygen. And that creates that H2O bond. Now that we have more basic understanding of how the valence electrons work and how to find them using a periodic table, let's talk about the 3 different types of bonds. The first bond is called an ionic bond. And this basically states that an atom either gains or loses valence electrons. Now think about it. If you're gaining an electron, you actually become more negative. If you lose an electron, you become more positive because electrons have a negative charge. A charged atom is called an ion. So if you think about it, an ionic bond basically means 2 charged atoms. And think about it, that positive and negative are actually what's going to attract it and create that bond. A good example of this is sodium chloride. Sodium has 1 valence electron, chlorine has 7, and there's very easily 7 takes over that 1, pulls it over to its side, and we end up with a positive and a negative, which attracts them and creates NaCl, which basically we know as table salt. The second type of bonding that we're going to talk about is covalent bonding. You might have heard like cooperative groups. The same applies to covalent bonds. It's actually a group work, and it's a group of atoms that are basically sharing valence electrons. Now, the best way to think about this is think about water. So back to the H2O. What actually happens is hydrogen and oxygen share those valence electrons between it. So it's not a taking and gaining or losing. What happens is that sharing. I like to think about if you have a sibling, you might share something like a bedroom. You might share a tablet or a camera or a laptop. That same sharing is what actually brings these atoms closer together. Now, if you have a sibling, you know the sharing doesn't actually happen perfectly equal. And that happens as well in atoms. If the sharing is equal, we call that a nonpolar covalent bond. If it is not equal, For example, if somebody hogs the Xbox the entire time, the other sibling gets very little time. That's basically called a polar bond, where basically the atom is pulling more on the valence electron than the other atom. And last but not least, we might have covalent bonds where instead of just one thing being shared, we have multiple things being shared. Maybe a double or triple bond that might occur in a covalent bond. Now, the third type of bond we're going to talk about is metallic bonding. And that happens between two types of metals. Now, ionic was between a metal and a nonmetal, covalent is between two nonmetals, and now metallic again is between two metal atoms. Now, what actually happens, instead of taking or sharing valence electrons, the valence electrons actually kind of move back and forth between the atoms. It's not stuck at one or the other. This is kind of the reason, the characteristic between metals, because think about it, the reason that valence electrons move back and forth is the reason the heat can move so quickly, sound, and basically this is why they're conductive. So you might have actually heard this as a sea of electrons because they swim back and forth. It's kind of a neat little analogy. Hopefully that might help you remember metallic bonding. And wrapping up kind of this video, just a quick reminder. You might actually think about these metallic bonds, covalent and ionic bonds in the way that the Lewis dot diagrams are. If you take a look at the dot diagrams again, we can see in an ionic bond, we can see that valence electron moving towards the empty spot. We can see in covalent bonding that there's a sharing going on, and last but not least metallic, we can kind of see that the valence electrons are actually moving back and forth or around the atoms. Thanks for watching this video. In the next few weeks, we're going to talk more about chemical reactions.